Good morning, everyone, and welcome to the May 2024 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Furman. I'm the Deputy Director of NOAA's Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Todd Hamill from the Southeast River Forecast Center, who will provide a water resources update, Pam Knox from the University of Georgia, who will provide an agricultural impacts update. And joining us today, we hope to have Dr. Pablo Mendez from the University of Puerto Rico in San Juan. We are having some technical difficulties right now getting Pablo on the webinar, but we hope to resolve that here shortly. And if he's able to join us, he'll be talking about various initiatives around heat in the U.S. Caribbean, including impacts, interactions, and adaptation actions. So again, thank you all for joining us this morning. Just a reminder to type your questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next day or so. All right, so let's get started with an overview of the climate. So temperatures over the past month were above average across most of the Southeast, with many locations running 3 to 5 degrees above average. It was also unseasonably warm across Puerto Rico, prompting at least 4 excessive heat warnings on the island. Data on the U.S. Virgin Islands just recently became available again, and so we hope to report on conditions there next month. Okay, next slide. One of the hottest parts of the region over the past month was South Florida. According to data compiled by Brian McNulty, Miami tied its third highest heat index value of 112 degrees on the 18th and 19th of the month, coming within 2 degrees of the all-time highest value of 114 degrees, which was set last summer. What's more remarkable, as we can see in the figure on the left, is that the 112-degree value shattered the previous record for the month of May by 6 degrees. And the heat index has already spent more time above 108 degrees than it has in an entire year since records began in Miami in 1948, and it isn't even meteorological summer yet. Now, in terms of air temperature, Miami recorded a mean daily temperature of 89 degrees on the 19th, which also set a record for May and ranks within the top 10 warmest days on record since 1895. In nearby West Palm Beach, the thermometer hit 98 degrees on the 15th and again on the 19th, coming within 1 degree of the warmest spring temperature in a record going back to 1888. The thermometer also hit 96 and 97 degrees multiple times during the month, and the month is on track to be the warmest May on record by a full 2.5 degrees. The record-breaking heat also extended down to Key West, which is shown there on the right, where the heat index hit 114 degrees on the 15th, also shattering its May record and coming within 1 degree of its all-time record. Okay, next slide. If we look at the month-to-date temperature rankings on the left, we see that several stations across Florida are on track to record their warmest May on record. If we combine this with the warmth over the past few months, we see that a few stations in South Florida, as well as a number of stations across Virginia and the Carolinas, are on track to record their warmest meteorological spring on record, while many more stations are on track to record one of their top 5 warmest springs on record. Okay, next slide. So looking at precipitation, we see quite a few areas that were wetter than normal, particularly across parts of Tennessee, North Carolina, and southern portions of Alabama and Georgia. It was also quite wet across parts of the U.S. Caribbean, including the Virgin Islands, where some CoCoRaHS observers have recorded over a foot of rain in the past 30 days. In contrast, drier conditions prevailed across much of the Florida Peninsula, as well as central portions of Alabama and Georgia, the Outer Banks of North Carolina, and western portions of Puerto Rico. Okay, next slide. So like we did with temperature, if we look at the month-to-date precipitation rankings there on the left, we see that some of those locations we just mentioned are on track to record their wettest or one of their wettest Mays on record. Looking seasonally, there to the right, we see that several locations from the Florida Panhandle up through eastern portions of North Carolina and Virginia, as well as much of Puerto Rico, are on track to record one of their wettest springs on record, while near to below average precipitation has prevailed across much of the Florida Peninsula. Okay, next slide. So no surprise, these precipitation patterns line up with the current drought monitor. Since last time, we see that the small pocket of moderate drought in western Tennessee was eliminated, as was much of the abnormal dryness that emerged across eastern portions of North Carolina. Very small pockets of abnormal dryness have since emerged across interior portions of the region. though the biggest change has been the emergence and expansion of moderate drought and abnormal dryness across South Florida, which is we've seen has been exceptionally hot and dry over the past several weeks. Okay, next slide. And looking in the Caribbean, we see that the region is currently free of any drought or abnormal dryness. Okay, next slide. So over the past month, the coupled ocean atmosphere system over the tropical Pacific continued to reflect a weakening El Nino. Virtually all models now indicate a transition to ENSO neutral within the next month, with about a 50% chance of La Nina developing sometime this summer, and a better than 2/3 chance of it developing by the climatological peak of the Atlantic hurricane season later in September. Historically, La Nina conditions typically follow strong El Ninos, and this adds to forecast confidence in a La Nina developing over the next several months. Okay, next slide. So speaking of hurricanes, last week, as I'm sure you all saw, NOAA released its initial forecast for the upcoming Atlantic hurricane season, which officially begins this Saturday. Specifically, the Climate Prediction Center places the probability of an above average season at 85% and is forecasting between 17 and 25 named storms. 8 to 13 of which are expected to become hurricanes, including 4 to 7 major hurricanes. Those are the category 3, 4, and 5. As we discussed last month with respect to the CSU forecast, confidence of an above average season is high due to the expectation of La Nina conditions, as well as warmer than normal sea surface temperatures across the Atlantic basin and an above average West African monsoon. More information on NOAA's forecast, including some enhanced communication and forecast tools for the upcoming season, can be found at the link at the bottom of the slide and will also be included in the webinar recap. Okay, next slide. So the active weather pattern across much of the region over the past several weeks has also contributed to quite a bit of severe weather, including high wind, hail, and tornadoes. Nationally, the number of local storm reports since January 1st ranks second since 2010, only behind the extraordinary year of 2011. So far this month, there have been 51 confirmed tornadoes in the Southeast. This ties 1984 with the 6th most tornadoes in the month of May since records began in 1950. The majority of these occurred during an outbreak that lasted from the 8th through the 10th, which also produced damaging winds and large hail, including a 3-inch diameter stone in western North Carolina, shown there on the right, the largest the region has seen in over 2 decades, and one of the top 5 largest stones on record since 1950. Okay, next slide. So as we look over the next 3 months, we see that above average temperatures and above average precipitation are favored across the entire Southeast region. Next slide. And the same holds true across the Caribbean as well, with warm and wet conditions expected this summer. Okay, next slide. Looking at the seasonal drought outlook, we see that drought removal is expected across South Florida, which is entering its wet season, while the rest of the region is expected to remain drought-free through the end of August. In the Caribbean, the expectation of above average precipitation, highlighted by the increased potential for tropical activity, means no new development is forecasted this summer. Okay, next slide. Looking ahead to next week, above average temperatures are likely across the southern half of the region, while above average precipitation is expected across the interior Southeast. Next slide. So if we look out to 2 weeks, we see a continuation of above average temperatures except across Tennessee, as well as northern portions of Alabama and Georgia, as well as a continuation of wetter than average conditions except across most of Florida. Next slide. And if we look ahead to next month, we see that above average temperatures are expected across most of the region, except the northern tier, which is also expected to remain wetter than normal. Okay, next slide. Should be our summary. Yep, here's our summary for you to look over after the webinar. I'm also happy to answer any questions at the end. I also want to acknowledge our service climatologist, William Schmitz, who helped compile much of the information. And with that, I'll turn it over to Todd.
Thank you very much. Morning, everyone. So it's interesting because as Chris mentioned, we've been kind of wet, but what does that mean for the Southeast, and what does that mean for flooding? So so you'll see on the left-hand side shows the USGS graphic that indicates over a 28-day average how our stream flows are going, and much of the greens and the blues show near average to above average for this time of year. And so those have had an impact on our rivers, and we have seen the rivers stay up, which is good news going into the summer. Oftentimes we get concerned about the rivers and the lakes and everything else starting to fall during the summer, and that's normal. But in this particular case, as we end May and start June, we're in very good shape going into the summer over most of the Southeast. As we look up in northern Alabama, it's probably a little bit less. We've got some spots that are showing some below normal, but overall across the Southeast, it's pretty normal. One other thing you will note is that in Florida, in central Florida, we see a mix of things. While we've had some dryness in those areas, a lot of time we're starting to get the afternoon type showers and thunderstorms, the thunderstorms that will produce a very spotty rainfall. And so you'll see where you'll start to see more and more as we look over the next couple of months where that can be a little bit more spotty unless we get widespread rain at this time of year in the form of tropical rainfall. So over on the right-hand side shows an overall look at the Southeast. And you can see that you'll see this pattern as we look at each of the states, because we have had a pretty good rain over each of the states during the last month. That while we were going down with climatology on a normal basis, in the last week or two, we have seen a bump up because we have seen that rainfall, and we have seen some heavier rainfalls that have kind of turned that tide against our climatology. So let's look a little bit more specifically at the states and go on to the next slide. So the Alabama, you can see, and you'll see that with each of these different states, is that we were following climatology. This year, while we started off dry in the fall, we got wet during the winter, stayed pretty much in the normal area in Alabama and in Georgia, both of those, and then began to fall off, as climatology says, down into more normal stream flows, staying in the normal stream flows and falling as we would expect during that time of year. But with the recent rainfall, we've had that bump up, possibly, it could be short, could be long term. Usually at this time of year with the competition for the water, it doesn't take long for that to turn. If we don't see rain for a full week or so, we'll start to see that turn back down and go back more to climatology. Florida's kind of always a different kind of animal just because they're going into their wet season right now. And so this is kind of their low time of year. As we've gone through their dry season, this is finally where they're getting a little bit lower. Now, with that being said, the northern part of Florida, the Panhandle, is a little bit different than the peninsula. The Panhandle acts more like the rest of the Southeast, and the peninsula from, say, certainly south of Jacksonville, the Melbourne area, we start to get Melbourne south, it acts more like a little bit differently. And we are really getting into the wet season now. And so we'll start to see that ramp up a little bit. But as Chris mentioned, they are seeing much drier weather. And so the drought is starting to creep into that area. So we'll have to watch that very closely to see how wet season affects that. And as the forecasters are looking at the drought going away in that area just because we are getting into wet season. So let's go ahead and go a little bit to our next slide and go a little bit further north into the Carolinas and Virginia. And again, a very similar pattern. As we've looked at some of these things, you will see that we're starting to jump back up. We were actually in the Carolinas starting to get into the below normal category as through that climatology. We were starting to really drop off. And this recent rainfall has really improved conditions over the state. Most of the people in those states will be very happy with that, because if we were getting into a drought this early into the summer, it could have made for a very long summer and into fall. So we're in good shape going into the summer, and you can see that with each of the South Carolina, North Carolina, and Virginia. Again, we're very similar pattern that we just saw. So let's go ahead and go on to the next slide. Because one of the things you'll notice, even though we have seen some significant rainfall and our climatology says we're above normal, you'll see that we don't have very much flooding in the Southeast. And that's typically because we don't see a whole lot of flooding during this time of year. you need some really focused rainfall in a given area to be able to do that. And a lot of times that will be with frontal systems that hang over the southeast. And then as we approach June and the July timeframe, it would be more in the form of tropical rainfall. And so we'll be watching for that to develop. As Chris mentioned, it looks like it's going to be an active year. However, that doesn't always translate to it being active in the southeast. Last year we had a very active year, but a lot of the storms stayed out to sea. So we'll have to watch that. But with an active year, it tends to give us a more opportunity to be affected by those storms. But most of our heavier rainfall, and I mentioned this before, a lot of it has been in South Georgia and in that northern Florida area. And again, this more acts like the southeast, and this is kind of the end of El Nino. We had stayed wet as we went into the end of the winter and into early spring, and we continue to stay wet in that area. It's kind of a remnant of what we would expect. And then we get into Central and South Florida, and things are a little bit quieter, and things have been a little bit drier. So really, that's the only area we have seen some flooding in parts of the southeast, but it hasn't been very significant, and it's been pretty quick for the most part. So let's go ahead and look at our climatologies on the next slide. And we're in week 22, and as mentioned before, we peaked back in that March timeframe, and now we're really starting to fall out. But as I mentioned, every time we talk about this, we can get flooding during any time of year, but it does take a lot more rainfall to get that kind of flooding, simply because we need a lot more rainfall when we have all the leaves on the trees, when we are greened out. It just takes a lot more water falling to the ground to get to the rivers and see flooding. And just it's with that competition for that rainfall and that water. So that's week 22. So let's go ahead and go to the Florida climatology. And this is where we start to see the ramp up in Florida. We've kind of come off our quiet time of year, and we're starting to spin up. So as the tropical season starts to spin up, and as those sea breeze type thunderstorms and those afternoon thunderstorms, the active time in Florida starts to spin up, this is what we'll start to see, that it should start getting more active through the rest of this year and through the tropical season. Our official start date is June 1st, so later this week, and then that'll go through November 30th, and that does get us through most of the tropical season, that peak in all that area. So let's go ahead and go to our next slide, and this is kind of the overview slide, and we're really at normal risk for flooding. We're not expecting significant flooding during that time, and what it will take to get us to flooding now is a long period of a frontal system being over the southeast and spending time in the southeast, or likely a tropical system if one develops and moves into the area. Those are the kinds of things we'll be looking for to see if we're going to have flooding in the southeast, because as you've seen over the last month, even though we've had some above normal rainfall, it hasn't been focused enough, and it hasn't been over a short enough period of time that we've seen any significant flooding over one particular area. We've had enough rainfall that have kept things in good shape, but aren't getting us into more of a drought. So right now, we're in very good shape, and we'll just be watching, and as we say, we'll be watching this very closely. And with that, we'll go ahead and go to the last slide, which is just my summary slide, and then and you'll be able to ask questions later, and we'll go ahead and pass it off to Pam to talk about the ag stuff.
All right, well, good morning, Todd, and good morning, everybody. Thanks for joining us today. Let us go ahead and go in to the first slide. Just some of the impacts we've seen on agriculture in recent weeks. Of course, we're in high gear right now. Everybody's working like crazy out in the fields when they can to get things done. The wet conditions have continued to hamper field work and hay production in some areas. Just because it's been so wet. And in fact, the number of days per week that were suitable for field work across the region range from just 3 to maybe 6 in some areas. So there's a lot of days when people just can't really get out into the field, and you'll see that in one of my slides in the future. The wet conditions have allowed a lot of fungal growth, fungal diseases in stems and leaves, and have caused some rot in strawberries. You can see a picture there on the top left of southern stem blight on tomatoes. And so farmers are having to spend a lot of time scouting for those, and when they can, applying fungicides to their crops. But you know, the timing is really hard to do when you've got rain falling almost every other day. And I also thought it was interesting that I got a picture from Rome Etheridge down in southwestern Georgia, showing that some of the fields even had fish swimming in them. You can see that in the bottom left there. I circled the fish. So it's been really, really wet in that part of the state and that part of the region, and that's caused some problems. Most corn has been planted now. Cotton and peanuts are still going in some places. The drought in Florida has been affecting the main citrus belt, and so that they've really been doing a lot of irrigation. Of course, almost every citrus farm there is highly irrigated, and so that is using up a lot of water. Hopefully next week looks like it will be a little wetter, and we're going into the wet season, as Todd pointed out, so that those needs should reduce over time. We've had quite a bit of severe weather that's resulted in some wind and hail damage to some crops in some locations. And I'm happy to say that this year the peaches and blueberries look great. They missed out on much damage from the frost that we had in March. And so everything's coming to market, and I think it's going to be a great year for those farmers, and boy, do they need it. Pastures generally look good. There's been some erosion from the rain, but overall, things are looking pretty good for them. If we go on, soil temperatures on the left there have been generally warmer than normal. Not surprising, because the temperature's been warmer than normal too. Maybe not quite as warm as it was last month. And so that's, since most things are already being planted, it's not a big concern at this point, but it's just something that we watch. Soil moisture, you can see that patch down in the southwest part of Georgia, stretching into the panhandle of Florida, where it's been so wet that they're having a lot of problems getting into the fields. There have been some dry areas, but see the dryness that was in eastern North Carolina has mostly disappeared, which is great news for the farmers there. If we go on, the rain, as I mentioned, is causing delays in planting and field work. You can see the percent of normal precipitation there for the last month, and most areas have been quite wet with the exception of northern Georgia and Alabama, and then of course in the Florida peninsula. So there's been just a lot of variation across the region in how much rain has fallen, and I put a map there on the right hand side that shows the observed total number of days with measurable precipitation for the last month. I know the numbers are small. You can go to the website and look that up later. You can see for Athens, which is just east of Atlanta, they have 14 days out of the last 31 days have had measurable rain, and that's in a top 10 for the number of rainy days for this year. And many of the other stations also are in their top 10. So it's been a wet year, and that's caused some frustration for farmers. If we go on, growing degree days because of the heat, not surprising. Growing degree days have been above average in most of the region. And you can see there, this is from AgroClimate. It's one of the monitoring tools that they have. The only place that's really been below normal in growing degree days is southern Alabama and the panhandle of Florida. And that's because they've had so many clouds from the rain that's reduced the solar radiation that's been coming in and keeping temperatures somewhat cooler. Also, when it's really wet, it's really hard to get those really high temperatures because most of the energy goes into evaporating water rather than raising the temperature. So if we go on to the next slide, this shows another tool from AgroClimate, which just shows how growing days have been accumulating over the season. I just picked from the last month. And you can see we're well above what we were last year, and we're also above the long-term average. And so that has really allowed the crops that have gone in to just really grow quickly. And there's corn now, I see that's tasseling and pollinating, and so that's in southern parts of the region, but there's a lot of things going on. Crops generally look pretty good. And so if you're interested in looking at this for your own area, you can go to the agroclimate.org website and see what it looks like for your own area. This only covers Florida, parts of Alabama, and parts of Georgia. So if you're in Virginia, you'll have to find a different tool, but there are some tools available from other sources as well. If we go on, here's my summary of the ag impacts and outlook, and I hope you'll take the time to look at these later. And now it's my pleasure to introduce Pablo Mendez Lazaro from the University of Puerto Rico is going to speak to us about heat in the Caribbean and also in the Southeast. So please take it away, Pablo.
Hi, Pablo. This is Meredith. I just gave you controls to become presenter. If that pops up, could you accept that, please?
Let's see if that works.
Excellent. We see it. It's just not in slide mode. Perfect. Thank you.
Okay, perfect. Thank you. Again, Meredith, I don't know why I'm not receiving the emails. So sorry. I didn't receive the link or anything. So sorry for being late. I'm Pablo Mendez Lazaro. I work at the University of Puerto Rico Medical Science Campus at the Environmental Health Department. And for me, it's a pleasure to be here and to be invited to share some of the works that we're doing here in the Caribbean region. In this case, I'm going to be providing more information specifically for Puerto Rico. I'm the principal investigator of the Caribbean Climate Adaptation Network, which is the first NOAA RISA for the Caribbean, which we are very happy to have one here. So again, thank you for the opportunity. How much time do I have, Meredith? 15 minutes?
Oh, you can go 20, 25 even if needed.
Okay, no problem.
We just want to have time for questions at the end. Thank you.
Okay, thank you. So basically, we have been working on heat with the National Weather Service, with the Puerto Rico Department of Health, and more recently, we are collaborating also with the Puerto Rico Department of Education. So we have one of the first early warning systems for heat in the Caribbean region. We have been working on heat since almost 14 to 15 years. And since 2018, we have in place an early warning system for the region, for Puerto Rico and the Virgin Islands. And now it's being more important than ever. Probably 10 years ago, 15 years ago when we started, yeah, we have been working on climate change and climate adaptation, but not many people, agencies or institutions were interested in this kind of product or this kind of information. But I can assure you that nowadays, a lot of people, organizations, and agencies in Puerto Rico are really interested and are paying a lot of attention to it. So, sorry. Okay, so why is important in this case in Puerto Rico when we're talking about heat, and why probably it took us so long to recognize this as a problem, and I mean as an island, right? And basically the message in the left side is one of the reasons why it took us so long. We live in a warm, humid environment, right? So because of that, the people often fail to perceive heat as a hazard. It doesn't mean that we have superpowers, that we are superhumans, but obviously, seeing apparently we are more exposed to these warm conditions, people start to perceive that this is not something that can harm you, that can do you wrong, that can impact also your public health. And it's far from being true, right? Again, as I mentioned, we don't have superpowers. So what I'm going to be showing here are different case studies and analysis, research that we have done, showing probably evidence on how heat is also being is impacting public health, is impacting multiple sectors in our society, energy production, our ecology, our agriculture, water availability, water resources, public health, and learning environments as well. So obviously, we are working with the National Weather Service and multiple other institutions on characterizing which are the heat drivers, because the conditions, the characteristics that are creating heat episode or heat waves in the continental US are very different from the conditions of what are creating or promoting this heat episodes in the Caribbean region. So for us, it's mainly the combination between the ocean, we're an island, so we're very influenced with the ocean conditions. So the water vapor, the humidity surrounding the islands is very important for that heat index, right? But heat index is not the only measure, but also to how do we, or heat sensation, right? So it's the combination of temperature, wind, multiple other drivers, what is happening in the regional context in the Caribbean region. So we have a pretty good understanding on the characteristics and the conditions that are creating this kind of heat episodes in the region. After that, we're also trying to understand the heat interactions. So it's not only looking at the atmosphere and characterizing the water vapor, the humidity, or temperature, sea level pressure, the sea surface temperatures, and multiple other conditions, but also how all these atmospheric conditions are being interacting with, for example, landscape. We're transforming the landscape. We are promoting urban sites. We're promoting urban heat islands. So with this landscape transformation, we're also modifying urban climate. And by modifying urban climate, we're creating new conditions in certain areas, right? So it's not only the characteristic of the atmosphere. So landscape is important. They were trying to understand as well the building designs, infrastructure, the capacity that the infrastructure can have to mitigate heat episodes in Puerto Rico. Also, the combination and the interaction with the social determinants of health. So Puerto Rico is getting old in terms of the population. So there is a lot of migration. We're not having too many births as we used to have 30 to 40 years ago. So there is a lot of elderly population now that is almost reaching 30% of our population. And children below 5 years old are only 3 to 5%, just for you to have an idea of what we're dealing. Elderly and children obviously are one of the most vulnerable groups in terms of age, but there are multiple other social determinants, for example, living below poverty level. So in the case of Puerto Rico, we're not only getting old, but also we have 51 or 52% of the population that are living below the poverty level. That means that they don't even have the budget to buy air conditioner or to pay for the electricity bill to keep the air conditioning running while you're suffering the heat in the Caribbean. Also, we're considering thermal comfort, and thermal comfort is something that is very individual for all of you. It's not the same thing. For example, let's think about that if you are a cancer patient that are going under treatment and you're receiving chemotherapy, cancer patients going under chemotherapy and treatment, they're more likely to suffer hot flashes, first of all, just because of the treatment. Second, when you're going under, and this is only one example, right, on how to consider thermal comfort and the complexity when we're talking about thermal comfort. It's not that easy to create big groups or big categories based on age or based on occupational issues. But for example, if you're considered also pre-existing conditions, it's more complicated than that. Cancer patients, again, they are more likely to suffer nausea, dehydration, loss of appetite, diarrhea. So during heat episode, they're also most likely to get deshydrated more quickly than other patients, for example, and just because of the treatment that they are facing, right? And so multiple other examples we can go on and on about it. The kind of exposure, which is also associated with your lifestyle and your behavior, and also your capacity to cope, that is tied into the social determinants of health. And then we can go into the consequences. So heat, after the heat drivers that are interacting with multiple factors in the middle, then we can go into the consequences of heat in the Caribbean region. And as I mentioned in the very first beginning, heat is already impacting food security in the island, human health, ecosystem, coral reef, forest, and multiple others ecological sites in Puerto Rico. Learning environments, our schools are being impacted already, as well as in many other places in the States. The energy system is not able to satisfy the energy demand when we're facing heat episodes in Puerto Rico. So the system is so tired after Hurricane Maria. Obviously, it collapsed. It was destroyed by one of the most powerful hurricanes that we faced recently, and it's still in a dire condition. So it doesn't have the capacity to mitigate or to satisfy the energy demand that the population is requiring during heat episodes. So we're seeing that kind of issue as well. So in continuity of operation for these essential services. Water availability because of water evaporation, and quality as well in our reservoirs. Most of the studies that are going to be showing here are part of partnerships, alliance, and collaborations that we're doing throughout SECAN with multiple institutions and agencies. And I would always like to highlight that this is not only that we are doing in SICAN alone, but SICAN as a network is leading all this partnership between different institutions to co-design solutions and also understanding, a better understanding of these kind of issues. We have multiple research done, for example, heat with urban areas. We do have evidence in Puerto Rico that we have urban heat islands, not only in San Juan, but in multiple other sites as well. We have evidence that the people are dying in Puerto Rico because of heat as well. So it's associated with people with diabetes, cardiovascular diseases, obesity, hypertension, multiple other pre-existing conditions that have been also identified in the literature in other places. So we have evidence that in Puerto Rico happen exactly the same thing, unfortunately. And we also have evidence that heat stress has been increasing in the last 30 to 40 years in the region, which is making more the situation more complex. And on top of that, heat in the Caribbean region is not only something that is happening in a season, during the summer season, but also we're seeing that as it could happen as a cascading effects after powerful hurricanes or tropical storm passing through the Caribbean region. There are some kind of changes in wind direction, in the amount of humidity, in the amount of energy, in the amount of sunlight that is creating heat episode in the aftermath of tropical storm passing nearby the Caribbean region, or when they're passing through on top of the island, crossing the island, for example. Just for you to be as a highlight, for example, after Hurricane Maria, that was a hurricane, very powerful hurricane that destroyed the whole island. We faced 11 consecutive days without energy, without green infrastructure, without water resources, 11 days of heat episode in Puerto Rico under dire situation. So you can imagine the aftermath, how difficult it was after Hurricane Maria. All of us are aware that the temperature has been continuing to increase. We face in 2023 one of the hottest years on record for planet Earth, and it's 2024 is looking pretty much similar. And I was reading a Nature manuscript that it was published, I don't know, last week, I think. And they were identifying also that 2024 is gonna be, yeah, for sure, hotter than 2023. So there is no coming back. This is not new. We knew already what we were talking about when we started working on heat 14, 15 years ago, many of you as well. So this is a reality. We need to be better prepared for what is happening. So looking at that scenario, we are working with vulnerable communities in Puerto Rico. We're working with urban sites on trying to minimize, to mitigate, and to help agencies in Puerto Rico to design strategies and adaptations for extreme heat. So we're using a human-centered design. Human-centered design in our network means that you start working with the people most affected by the problem to be solved. It can be an agency, it can be an institution, it can be a community, or it can be a group of individuals. So we're working with community residents, we're working with agencies in co-designing strategies for heat. When we're talking about vulnerable communities, sometimes we're only thinking about these big groups that NOAA is promoting, which is pretty good. It's like the ICD-10, right? You are creating these big groups to have a better understanding of the amount of people that could be at risk, right? When we are facing heat episodes. But also there are multiple other compound rates that need to be understood. And this is an infographic that it came recently released in the National Climate Assessment in the overview chapter, which is also taking under consideration location to see if you could be more vulnerable or not, social and racial factors, compound risk, and economic situation. As I mentioned, if you're living below poverty level, you're more likely to suffer heat than other communities, for example, that are living in high income communities. So those kind of things also are part of this description, because if you're pregnant or you're elderly or you have a chronic illness but also you're living, you have another combination that you're living below poverty level, obviously that makes you more vulnerable than some other. And you're living in the hottest places in the city, again. So those are compound factors that you can add to your vulnerability. So working on that, we're working with Landsat to understand the distribution in Puerto Rico on the communities, and I'm going to go very quickly. Working with the social vulnerability index from the CDC, we're merging this kind of information probably for the first time in Puerto Rico, because most of the cases in Puerto Rico we don't have this kind of information available. So we're very happy that finally federal agencies are also moving forward to capture this kind of information for the Caribbean region. Just for you to be aware, in the census, this is very weird, and this is, I don't know why this is happening, but for example, in other territories like Guam and in the Pacific Islands, the United States in the census are asking if the households and the communities, they do have air conditioning. But in Puerto Rico, they're not asking if we do have air conditioning, but they're asking if we have heat in the census, which is, again, completely weird. But just for all of you to be aware that the gap of data that we have also. But I'm happy that at least with the CDC, the social vulnerability index, we're moving forward in some areas that are important for us to have better decisions because we have better information. So we're working with this information and helping also to identify where these vulnerable communities are living and if they're being more exposed. So this is information that the agencies can use not only for preparedness and emergency management, but also if you would like to address capacity buildings, educational materials. You can also address target messages to this population. You can say, okay, so people that are living in these areas are being more exposed to heat. Could it be, again, that is more likeliness that you could be more exposed to heat than if you're living in some other places. But it's information that we didn't have it available before, and now we have it here. I'm going to go very quickly. Unfortunately, as I mentioned before, people are dying in Puerto Rico. We don't need to have a heat episode above 100 degrees Fahrenheit. People are dying already when the temperatures are increasing above 90 degrees Fahrenheit. And this is not only, this is without considering water vapor or some other multiple other factors that are exacerbating the heat sensation, right? Like heat index, for example. But unfortunately, after 90 degrees Fahrenheit, we are seeing an increase in the relative risk for mortality. In the case of Puerto Rico, this is a pilot project that we did for the San Juan metropolitan area. A dissertation thesis that a student of mine did a couple of years ago, we also found that there was a 6% increase in hospital admission for cardiovascular diseases for every 1 degree increases in degrees Fahrenheit with people 65 years old or older. And again, considering that the profile of the population in Puerto Rico is getting older, and we have more elderly population than we used to have before. So, but we're getting also hotter. This is a perfect storm if we don't take actions to protect this population. In terms of heat stress is increasing in all of the seasons, unfortunately, for the whole region, which means that it's influencing also the local conditions in the Caribbean region. We use the UTCI to estimate this, and the UTCI is pretty much similar to the wet bulb globe temperature. It's an index that mostly the European Union is using. So we use it for the Caribbean region as well. We calibrate the satellites, we validate it. This is with satellite information. It's an equation. Again, it's like the wet bulb globe temperature, that is considering temperature, wind direction, wind speed, and multiple water vapor, multiple factors, sunlight. And what we found, unfortunately, as well, is that UTCI is highly related with an increase in mortality in Puerto Rico. We analyzed daily non-accidental mortality since 2015 to 2020. More than hundreds of thousands of deaths in Puerto Rico that we analyzed. And unfortunately, island-wide, we're seeing that myocardial infarction, there is an increase of 16% when UTCI is above 33 degrees Celsius in this case. Heart failure is almost 55% increase. That's huge. 82% for cerebrovascular diseases and 78% for cardiovascular diseases. So again, this is showing a lot of relevance that in the Caribbean region, we don't have superpowers, and unfortunately, we're being impacted as any other places in the world. But beyond that, I think that other places, at least, they have an advantage that they are already been working on heat adaptation. But in the case of Puerto Rico, as I mentioned, people used to perceive that heat is not a hazard. Now things are changing after 2023. People are noticing that effectively heat is becoming a real issue and a real problem in the case of Puerto Rico, right? So yeah, this is another way on how to show the information that I was just explaining, but unfortunately, yeah, we don't have superpowers. And this is more graphic on how to see an increase in mortality, non-accidental mortality in the case of Puerto Rico. With all of this information, we started working with the National Weather Service back in 2012, and we started developing the first early warning system for probably the Caribbean, I would say. We started with temperatures, and we moved to heat index, and now we continue evaluating what kind of information should be provided for the public to take precautionary actions. And this is something that we did together with the National Weather Service and the Department of Health, and not the Department of Health, sorry, with my department, the Department of Environmental Health at the University of Puerto Rico. But the Department of Health collaborated with us as well in some analysis and to have a better understanding. This is far from being perfect, but we have in place at least one tool that is operational, providing information about heat conditions for the population to take actions. And we can see that, for example, the PREPA, which is the Puerto Rico electric system, is taken under consideration all these heat warnings that the National Weather Service is issuing. And now they are already using this information also to alert the clients and the residents in Puerto Rico that they might lose electricity because of the heat wave. So since there is a likeliness that we will have heat episodes, they are expecting a lot of energy consumption, and because of that energy demand, they don't have the capacity to satisfy the demand, so they are expecting for the system to collapse, right? And they are already issuing this kind of alert to the population, which means that it's not the best. This is the perfect storm, right? When you are receiving a heat wave, it's not the best moment to lose your electricity. If you have elderly, if you have people with pre-existing conditions in their beds, in their house, and they don't have a way on how to mitigate that heat, that's becoming a real issue. So where we are in terms of the heat advisories, in terms of numbers of heat advisories, as you can see, since 2019, we put it operational in 2018, and we're seeing an increasing trend in terms of the numbers of advisories that the National Weather Service is issuing for Puerto Rico. So we started with a couple of them back in 2019, 5 to 10 per year, a couple of 20 in the 2022, but if we can see the 2023, we are seeing that we're above 140 heat advisory during 1 year. That's huge, right? Never seen before in the case of Puerto Rico. So there is a clear increasing trend in terms of the number of days that are above the 90th percentile for both minimum temperatures and maximum temperature in Puerto Rico. So we need to take actions. These are the products that the National Weather Service are issuing for the island, and also including Virgin Islands. And as you can see, so in most cases are the coastline, where we have 60% of the population living in that area. In the central part of the island, with the elevation, with the forest that can provide ecosystem service, such as regulating temperature, because there is a lot of green areas. So there are not too many heat advisories, but as soon as you go to the coastlines, you are seeing that there is a high chance of receiving these kind of warnings. And again, 60% of our population live in the coastline. With all of this information, finally, we make a decision to say, okay, so I think that we need to do like a summit to gather together all of the different sectors that are working on heat in the case of Puerto Rico and Virgin Islands. I think that we had the traction to do it. this is the moment. And absolutely, we did it right. When we try to do this kind of meetings with different agencies, with the National Weather Service, explaining them what we were doing, we were able to capture 10 to 15 people together in one room. In this case, we had the opportunity to gather together almost 200 people for 2 days, working from architects, engineers, public health, teachers, different kind of sectors, working together on heat adaptation for Puerto Rico and Virgin Islands. So it was an amazing moment. Chris came to Puerto Rico. Thank you for coming. We have FEMA, we have multiple others people working on this, and we're working on the suggestions and recommendations that it came out of this summit. And with this information, we have been meeting with Puerto Rico Department of Education frequently, almost all the weeks. So we decided to make also a survey, because Puerto Rico Department of Education have identified that heat is also affecting their learning environments, not only their kids, but also their employees. And when we're talking about employees, not only the teacher, but also administrators, also people that are working as a security guard, maintenance, landscaping, everybody that are working in the learning environments are being impacted. So we're doing a survey with them in order to understand also the impact, perception, right, risk and barriers of the employees that are working in the school of Puerto Rico, and we're working on different regions. We received the information from the school. We are pinpointing the school distribution in the island, and we're identifying also categories for this, for all of the schools in Puerto Rico. Take under consideration that only 49% of the school, they do have air conditioning. So if you're wondering, and only out of the 49% of the school that have air conditioning, only a few percentage of that have the air conditioning working properly, meaning that because of lack of maintenance, because of the lack of electricity, because of the system collapse, they don't have the capacity to turn on their air conditioning. So the vast majority of the school in Puerto Rico, they don't have air conditioning. So we are helping the Puerto Rico Department of Education to identify the level of risk that all of these schools are exposed based on the land surface temperature. We know that land surface temperature doesn't mean air surface temperature. It's not the same thing, but it's a proxy at least to start understanding the possibility of being exposed to the hotter places in Puerto Rico. And we have information on where are the schools that are more likely to be exposed to heat. And in this case, for example, we can identify that the region of Humacao, which is the one on the left side, only 20% of the schools are being exposed to high level of risk of heat. While if we go to Ponce, which is the other side in this graphic, we can see that 51% of the school in Ponce are exposed to the hottest places in Puerto Rico, right? So we need to pay attention probably to this region because they have 50% of the school, and we need to understand what kind of kids they're serving, they're providing services, right? If they have autism, if they have Drought syndrome, what kind of population also they are servicing in this school that have been identified to be exposed to the hottest places of Puerto Rico. So we have a school per school. So and we're doing now, this is information that have been so useful for the Puerto Rico Department of Education, that we're doing a summit with all of the school directors on June 3rd. That actually Chris is being invited as well to give us a talk about the wet bulb low temperature and how can we help to work on it. So it's going to be an amazing activity. So it's getting a lot of traction, this kind of topic in Puerto Rico, and hopefully we'll be able to start working on adaptation strategy finally to protect our population. And this is it. Thank you.
Pablo, that was fantastic. You and your team are doing such important work, and we really appreciate taking your time to share us both the science and the action to address this very disturbing trend and risk. My name is Meredith Muth. I work for NOAA's National Integrated Drought Information System, one of the organizers for this webinar series with the Regional Climate Center of the Southeast and NOAA's National Weather Service. We will have time for a couple of quick questions if you'd like to enter those into the question box. We will send out a recap of this webinar as well as a recording probably tomorrow. Feel free to share that. We also have our next webinar on June 25th. We'll be going into more detail about the 2024 Atlantic hurricane outlook. And then in July, we will again talk about heat, which is so important for this region, focusing on urban heat. And when we're done here, a quick survey will come up. If there are other topics you'd like to hear about, please let us know and we'll do our best to address those. Okay, I have time. I have a couple of questions here. The first question, Pablo, is for you. It is from a listener who mentioned a heat dome that is occurring right now over Mexico. And the question is, does this heat dome extend east over Puerto Rico?
Oh, thank you for asking. It's not necessarily the same conditions, but yes, we have been experiencing for the last 2 to 3 days the heat episodes in Puerto Rico as well. Yeah.
Okay, great. Thank you. And I have another question. You talked about the increasing trend of excessive heat. Can you speak at all about looking ahead and climate projections for the region and what you see in terms of where that trend is going in the future?
This is for me as well, Meredith.
Yes, that was for
Okay.
you, Pablo. Sorry.
Okay, sorry,
Apologies.
not a problem.
About
Sorry, okay.
temperature.
Okay, so yes, I had the opportunity also to lead the chapter for the Caribbean region in the NCA 5, the National Climate Assessment, which is now available in both languages, in Spanish and English, in the webpage. So what we found and what we're seeing is that temperatures will continue to increase in the region. Unfortunately, it doesn't matter the kind of scenarios that we are analyzing, there is no coming back. In the worst case scenario, so yeah, temperatures are increasing more rapidly, but in the best scenarios, they're not increasing that quickly. But yes, unfortunately, the trend will continue, and projections are that we are expecting a warmer climate for the Caribbean region.
Great. Thank you, Pablo. We'll make sure that we add a link to the chapter for the U.S. Caribbean from the 5th National Climate Assessment. We'll make sure we add that link in the webinar recap. It's a really important chapter. I encourage everyone to read that. Are there any last comments or questions from any of our wonderful speakers, Chris, Todd, and Pam, as well as our guest speaker today, Pablo? Okay, and then with that, we're at the top of the hour. I hope you all stay cool in the Southeast this summer. And again, thank you so much to all of our speakers, especially Pablo, who joined us. And we hope to see you next month. Thank you.
Thank you.